All right, we are now looking at 5B.2. Our mastery learning objective is I can calculate conditional probability by interpreting two-way frequency tables. Okay. So the definition of conditional probability is the probability something happens given something else has already happened. Yeah, sure. We'll pretend that's what's happened. Okay. The best example I have of this is like the probability of passing a test given that you studied. Your probability of passing a test given you study is going to be higher than your probability of passing the test given you didn't study, right? So depending on what you've done before, it can change the probability of what's going to happen in the future. Okay? So we call that conditional probability. We have a formula for conditional probability. Our conditional probability is the probability of one event, we're going to call it event B, given event A that has already happened. So again, this line means given. B happens before the line. A happens after the line. Makes sense. And this probability equals the probability of A and B divided by the probability of A. Okay, so we're going to use what we just did in 5B.1 to find these probabilities, and then we're going to divide them. Okay. So using the table to the right, find the following probabilities. So the first thing I'm going to do is I'm going to put a B before and an A after. That way when I copy down this formula, the probability of A and B over the probability of A, which equals, well, A and B is the probability of being a girl and being in 8th grade over probability of A. Well, A is girl. I'm just going to fill in with my numbers. The probability of girl and 8th grade. Being a girl and being in 8th grade. They cross right here at the 12. All over. This is a fraction within a fraction. The probability of a girl. Well, there are a total of 27 girls. Okay. The easiest way to do this is if you look, you have a 50 and a 50. My 50s cancel. And I'm left with 12 out of 27. You still have to simplify your fractions. Okay? Both of these can be divided by 3. And you get 4 out of 9. Again, feel free to use a calculator to do these, especially on quizzes and tests. But again, as our SAT has a non-calculator portion, we want to make sure that we know how to do it without a calculator as well. Okay, some of those basic fraction things. And that's it. It's not too bad. It's just writing down the formula, which I would do every time so that you make sure you have it right. Let's look at letter B. Same thing. This one is almost identical. But look, now my B is girl and my A is 8th grade. So when I do the probability of A and B over the probability of A, I'm really doing the probability of, well, A is 8th and girl over the probability of my A, which is 8th. Okay. Again, 8th and a table and tells me where they cross. Well, 8th and girl, hey, it still crosses at 12. That probability is the same. 12 out of 50. I'm going to write 15. And then now with probability of 8th, right, all over the probability of 8th grade. Well, if I look at all my 8th graders, there's 22 of them out of 50. Okay. Again, these 50s cancel. So I'm left with the 12 and the 22. Both of those can be divided by 2. So I'm left with 6 11ths. All right, let's look at another example. Boy given 7th grade. Right. Again, our formula is the probability of A and B over the probability of A. Again, B comes before, A comes after. I know we want to go in alphabetical order, but it doesn't work that way. So A and B is the probability of 7th and boy over probability of A is 7th. Well, our probability of 7th and boy, where boys and 7th cross is 6. So that's going to be 6 out of 50. I'm going to move that up because we have to divide. So 6 out of 50. All over. Our probability of 7th, if we look at our table, there are 13 people in 7th grade. Okay. Again, our 50s cancel. And we're left with 6 over 13. 6 over 13 does not reduce, so we can leave it like that. Again, similar here with 7th grade given boy. But now, again, this is our B and this is our A. So again, our A and our B switched. So we're going to do the probability of A and B over the probability of A. Well, A is boy. and 7th. Now I'm going to divide by the probability of A, and my A is boy. Look at being a boy and being in 7th grade. There are only 6 people who are boys and in 7th grade. And then divide by my probability of being a boy. Well, there's 23 boys total. Okay. Then again, my 50s cancel, and I'm left with 6 out of 23. Okay. All right, 2 more examples. Almost done. Right, probability of 6th grade given girl. Okay. Again, our formula is probability of A and B over the probability of A. Again, B comes before, A comes after. So we have a probability of A is girl and B is 6th grade over the probability of A, which is girl. Which equals, well, the probability of girl and 6, again, if I look at my table, if you're a girl and in 6th grade, there's 8 of you. So 8 out of 50 are girls that are in 6th grade. Out of the probability of a girl, right? Well, there are 27 girls. Again, at the end, cross out your denominators. So we have 8 out of 27. 8 out of 27 does not reduce. Last problem, boy given 6th grade. Again, the probability of A and B over the probability of A. Again, B comes before, A comes after. So we're doing the probability of boy, no, A and B, which is A is 6. And boy over the probability of A, which is 6. If we look at our table, for boy and 6, or 6th and boy, there are 7 of them. So we have 7 out of 50, all over, probability of 6th grade, and there are 15 people in 6th grade, so that's 15 out of 50. Which equals 7 out of 15. All right, and that is it. Again, that one also doesn't reduce. So you always have to check if it reduces, but if it doesn't, you get to just say, yay, I'm done. I believe that is it. So go ahead and start working on your 5B.2 activity.